Please be mindful that when your calculator gives you an answer, make sure that you're reading the entire numerical value of that answer. So for example, in this particular problem here, we're looking at the distribution of male heights, where we know that the mean male height is 67.9 inches with a standard deviation of 3.3 inches. So in this particular problem, we want to know what is the probability that a randomly selected male has a height that is less than 55.8 inches. So to answer this question, we're going to use Normalcdf on the calculator because we're trying to calculate a probability. So anytime you have a problem where you know that your data has a normal distribution, draw yourself that bell-shaped curve. So here I've drawn that bell-shaped curve, and I've labeled the heights that are 1, 2, and 3 standard deviations below the mean, and then right below that I've got the corresponding z-score. So we can see here that I'll mark in red here, 55.8 inches or less is on the left tail here. So you can't really see it, but the probability is that red shaded region. So that's the probability that a randomly selected male height is less than 55.8 inches. So when you go to your calculator and use that function Normalcdf, you're going to put in a very large negative number, which is -1e99, which is the same thing as -999,999. And then your upper limit is this value right here, which is 55.8, okay? And then you're going to type in mu and sigma. So when I press enter, take a look at the solution that my calculator gives me. The most common mistake that students make is they write down that that probability is 1.22. But you know that 1.22 cannot be a possible probability because probabilities are always going to be a number. So probability is always going to be a number between 0 and 1 because the entire shaded region under the curve, right? The entire shaded region has a probability of 1. So if the entire shaded region has an area or a probability of 1, then when we take a look at just a portion of that distribution, it has to be a number between 0 and 1. In other words, a decimal. So when you take a look at your calculator here and see that it has this e -44, that's your calculator's way of writing a number in scientific notation. So if you guys remember scientific notation, this number means 1.22, I'll just round out to 9, times 10, so your calculator uses e instead of times 10 to the -4. So if you guys recall scientific notation, if you've got that 10 raised to a negative number, that means take your decimal and move it 1, 2, 3, 4 places to the left, and then that gives you the value of that number. So this tells us that, I'll write down at the bottom here, 1.229 times 10 to the -4th is the same as 0.0001229. So that's your probability, but we want to write this as a percentage. So if you want to turn a decimal to a percent, once you have the decimal, multiply it by 100, and that gives us 0.012%. So notice that's a very small percent. It's way less than 1%. And we expect it to be very small because take a look at this whole region right here is a very tiny sliver of the entire distribution. So the probability that someone is going to be less than 55.8 inches is going to be a very small probability, right? In fact, that probability is approximately 0.012%.